Hi, everybody. My name is Michael Lane. I'm the president of LiftPort Group, and I'm really glad that you are here. With me are Sean Key and Jonathan Connell. That's our core team. We've got one other person waiting in the wings, and we've got an intern showing up later in the month. But that's who we are right now. There's some stuff that we're going to talk about and expand, but for now, that's where we are. Sean, can you give a little brief description? We've got about 10 minutes for this section, so give a little bit about your background, who you are, what you're doing, and your role here.
Okay, my name is Sean Key, and my bio basically is I'm a veteran of the military with the United States Army. I was a paratrooper specializing in behind the lines reconnaissance and intelligence gathering. Got out, went to college, wound up interning with LiftPort, the original LiftPort when it was Earth-based. Whenever it shut down, did some odd jobs here and there, was working in a bank for a while. Went back and got my MBA with concentration in finance, which is what my interest was. And then eventually I had to leave the bank and decided to come back to the space industry, which I always kept tabs on it. And that's me, my progress into the industry. Wound up working with Michael. I am the CEO of Better Futures, which is focused on the intersection of money and space and deep tech. I'm also the developer of the tier system, which is a methodology that we use to calculate risk and chart it as technologies mature from theoretical all the way down to basically infrastructure.
And we're going to talk more about all of that in a little bit. Go ahead, John.
Yeah, Jonathan Connell, grew up in England, arrived in America 30-something years ago, lived in New York for many years, and I've been in Seattle for about 10. I studied electronics, so that's my specialty if I have one. But I've always been interested in space, and I've read literally every edition of NASA Tech Briefs since about 1994. And I have a memory that keeps this stuff. I got the opportunity to get into space when Gravitics needed somebody to run their prototype program. I've got a long track record of building difficult things quickly without spending a lot of money and cutting through a lot of the crap and getting something done and getting companies funded. So Gravitics were attracted to that. And I built their first prototype, the big thing that you see in all the media, the big metal water heater, 40 foot across and 40 foot tall. My team built that, and we did that in, I think, 6 months, and we got $20 million for a truck. So I don't think it's straight lines. I get things done differently, and in regular industry, the whole build, test, iterate that is vaunted in the industry right now, we were doing that 30 years ago in regular manufacturing. It's second nature. And one of the issues I have with space in general is we're so used to preserving life and increasing safety that the trade system does it in the wrong place at the wrong time and costs us a lot of money and competitive edge. So I try and remove that from the equation. And now I find myself working at LiftPort, trying to do something that a lot of people think is impossible, with some really interesting challenges. I've done a lot of math simulation in my time. I've published in learned journals, and the math we have to invent in some cases to look at our system is really challenging, and it's never been done before the way we're going to do it. So the math,
boy, do I feel that all the time. It's never been done before. Shout out to Joe Luttrell, one of our contractors, and Wes, also another contractor. Thanks for being here, y'all. If somebody could send a message to Mr. Lauren and tell him he's in the wrong spot, that would be helpful. All right. So what's the purpose of this show? So by way of introduction, if you don't know who I am, I'm Michael Lane. I'm the president of LiftPort Group. I've been involved with space LA research for a really long time. Depending on how you count it, it started in 2001, 2, and 3, working with the NASA research team on the space elevator, working with them as a contractor. Then moved on to create LiftPort when those original funds, research dollars, ran out. Ran the first version of LiftPort from 2001, 2, and 3. Sorry, 3, 4, 5, 6, and 7. Focused primarily on nanotech. That was our start. We were working on carbon nanotubes. That was a pretty big botch. Went completely the wrong direction and spent a lot of money learning that way. And then got pretty good at climbing string, tethers, tied to high altitude balloons, climbing back and forth. And that was great. We learned an awful lot from that. And I thought we were on a pretty good path. But little known fact, the project was funded primarily, not entirely, but primarily from my own real estate portfolio. And when the real estate markets collapsed, we got destroyed. It was sudden and dramatic and uncomfortable. So that put the first version of LiftPort out of business. Went on to school. Went back to school. Went to International Space University for a while. That was terrific. That's when I started looking at the idea of a lunar elevator. If we couldn't build the Earth elevator, what could we build? And that was the starting point. I really officially kind of shifted gears maybe in 2009 and 10 to exclusively work on this as I got more and more frustrated with the lack of progress on the Earth elevator. And then over time, as the world kind of moved and changed, satellites became more and more and more and more common. The Earth elevator looked harder and harder. More debris happened. The Earth elevator looked harder. Better rocketry and reusable launch. The Earth elevator looked harder. But each of those changes actually made the lunar elevator more and more interesting. So I tried another false start in 2012 and 13 and 14. It was still ridiculously premature, but when I started again in 2017 and 18, that's when things started to really progress. We started making real progress. We had a small team. And by the time 2020 rolled around, I thought we actually had real support and real funding from the government, from the federal government. When March 2020 happened, a lot of our allies had other things on their mind, and suddenly we were not a priority for anybody. And that was pretty tough. So that was yet another version of trying to build this company. And so that's where we are now. The beginning of last year, I put a small team together and said, this is it. This is what we're going to do. And most of 2025 was putting the foundation together. And at the very beginning of this year, January 8th, we put a stake in the ground. We said, all right, this is it. It's going to happen this time. And we built a website with a countdown clock, and it says 1,000 days, 1,000 days to first launch. Yeah, tick, tick, tick. Exactly, John. And it's spooky, right? Today we're at 902 days. It's kind of crazy that we've burned 10% of our time just in the organizational and development side of it. But we have, but that's still okay. I think we have a plan. I think we've got a good team, and it's the beginning of something really remarkable. We decided that we were going to have our first lift on October 4th, 2028. and we're sticking to that as a deadline. So it's bold, it's hard, but that's where we are. Do you guys have anything to add to that?
Yeah, just talking about you, Michael. I got off a plane from Space Symposium about 90 minutes ago now, and this is what I was wearing at Space Symposium. I met hundreds of people at the show, and you shake hands and they say, "What do you do?" And I LiftPort described what it was, and 8 out of 10 people at that show said, "Oh, that's Michael Lane." So 8 out of 10 people at Space Symposium know who you are.
That's higher than I thought. That's kind of awesome, actually. Thanks. That's fun. That's fun. I didn't know that. Sean, you got anything you want to chime in there?
No, I've known you for quite a while. We've actually had another adventure in the media publishing part, trying to make like a Huffington type post for technology. But I've always been hooked on this. I've been a fan of the space elevator, and when I got a chance to reconnect with you and said, "Let's see this thing through," you had an opportunity, and I said, "Let's go for it. Let's see if we can make this work."
Right on. All right. So in our next 10 minutes, I kind of want to zip through a couple really important things, and then we're gonna bring on a guest. But to start, I want to tell you kind of where we are. We are beginning a capital raise. I told you this 1,000-day countdown clock. It doesn't happen without money. It doesn't happen without a lot of money. So specifically, let's talk about that. There's 3 phases: phase A, B, and C. Phase A is primarily digital only, right? That's what we're doing. It's going to be ones and zeros. We're going to build as much as we possibly can in the very low expense environment of ones and zeros, and building out simulations, using artificial intelligence, and as much design work as we can now while it's relatively cheap. But that's still $20 million. And that $20 million is what we think will catalyze how we reach that 1,000-day time frame. We do have a secondary budget that's only $5 million, but if we do it with that, then we're probably going to take 5 or 6 years to build it. So our capital raise is in phase A, 500,000 immediately, 5 million as fast as possible, and 20 million this year. And if we can hit those 3 marks, then I think we're on track for that 1,000-day mark. So that's phase A. Phase B is when we test what we learned on the digital side, and that means going into the sky. That becomes immediately expensive, where we're building hardware and launching hardware. But if those two plans work, then phase 3 is build it and deploy it. And candidly, building and deploying is not as hard as a lot of people think. Like if you've been following kind of generic space elevator research for 25 years, everybody thinks it's super, super, super hard. But the lunar elevator is buildable now with current technology. All we have to do is build it and assemble it and deploy it. So that's it. That's the plan. A, B, and C, 20 million digital, 30 million hardware in the sky, 300 million construct and first deployment. So that's the plan. I know I've oversimplified it. I know that I have. We only have a few minutes to talk about it. We're putting a bunch of stuff on our website, so go to liftport.com for more of our more detailed reports. And within that, we're in phase 1, phase A. We're developing our budgets and our pitch decks for the 500,000 and the 5 million right now. I have our very first pitch, our very first ever pitch, next week, a week from now, next Wednesday. So fingers crossed. Yeah. Anybody got anything to add to that piece?
I what I kept hearing at the show was that people think a lunar elevator is an Earth elevator. They think it runs from the moon to Earth, and we really have to stress that it isn't, because they say what I said when I first met you: isn't that impossible? We haven't got the materials yet.
Right.
And the thing to drive home about LiftPort is it uses standard available materials. There is no new technology needed. We can do it right now with stuff that's been around for 10 years. So it's very important. And we don't go all the way to Earth. It's not an Earth elevator.
Right. Right.
Yes, I agree. That's I second that 100% because what attracted me to the first elevator, space elevator, was the economics behind it, the follow-on technology. But whenever it failed, and then we talked about you can do it with the lunar elevator with today's technology that exists now, that becomes a much more compelling argument, and the economics behind it is much more compelling as well.
It really is. It's the kind of like psychological breakthrough it took to decide, okay, now is the time. That wasn't easy and it wasn't obvious. So it's kind of fun. It really is. It's kind of fun now.
I truly believe that what we've got here is the transcontinental railroad is going to have that same impact on cislunar space that the transcontinental railroad had on California. It's going to change the equations and the amount of material we can move back. It's going to be a step function of change.
Exactly.
Yeah.
Exactly.
And just like you might not see the economic drivers at first, it's once you lay it out there and it opens it up, the economics will start to kick in. Now you have an easier access onto the lunar surface and off the lunar surface.
It's the thing that you do with the thing. That's the thing.
Yeah.
That should be a great bumper sticker. It's really a convergence of 5 core technologies, right? So materials, as John just said a moment ago, it's always been the showstopper for the Earth elevator. So people made the assumption it was a showstopper for the lunar elevator. It definitely isn't. There are 14 candidate materials that are all strong enough. Is launch a showstopper? No, we've got a massive decrease in launch costs, massive new capacity coming online. In a few hours, Blue Origin's going to add to that with a brand new flight. Computing and simulation. Now that definitely is a game changer. Computing and simulation combined with AI and autonomy, those are new. Those weren't in our slide deck 10 years ago, right? None of this tech that's available today was available 10 or 15 years ago. Those two things are game changers. And finally, communications, right? Those things, all 5 of them together, space relays, laser comm, the infrastructure that is heading towards the moon is unlike anything we've ever imagined before. So that it changes. Everything is changing, and we're hoping that we are kind of on the same convergent path that everybody else is on. I'm gonna, looking at the clock here, switch gears super fast to talk about our new effort. And by the way, is our guest here? He is not. Sean, can you ping Eric, please? Do it in Slack, probably. I'm going to take a moment and talk about one of our newest initiatives. We're launching it officially today. It is the Industrial Infrastructure Network. And that is great. Eric just joined. Perfect. The Industrial Infrastructure Network has been kind of in development for a little less than a year, but it's the idea that the world needs a chamber of commerce for the moon. Now, that's a little grandiose and seems a little kind of off path for us, but talking to Sean and talking to John, what we've decided is that if we build the right community, the right network, it has this incredible multiplier effect, right? There are about 50 to 100 funded companies aiming for the moon. We don't know that hard number. We know that there's more than 3,000 funded companies in the sector, but most of them are focused on low Earth orbit. But out of that universe of 50 to 100 lunar focused companies, they're not really working together. They're not really communicating and coordinating. But if there was an organization like us that needs these people to communicate and coordinate, it's in our advantage, it's to our advantage to help solidify that. So we're putting together a network. It's expensive. It's expensive by design because we want it to be a gatekeeper organization. It's $1,000 a month to join this network. But the idea is that all of these companies will stop reinventing the wheel and post their wants and their needs and their offers and opportunities to each other so that they don't have to keep reinventing the wheel in-house. So that's our hope, that's our goal. And that is a surprise to everybody because that is a revenue stream for LiftPort. And most people don't think that Space Elevator Company has a revenue stream until you get the whole damn thing built. And that's not us. So with that, I'm going to pull in our friend Eric. Hey, how's things?
Things are going very, very well. Great to see you guys.
Good to see you. Good to see you. I'm going to ask you to give, I'll just do a brief intro. We've got 3 of our contractor partners on this call. Eric is the first one up. So with that, Eric, can you give a little bit about your background, your origin story? We've got about 18 minutes to chat.
Yeah, no problem. Thank you. My background, I went to school and got my bachelor's, master's, and dropped out of my PhD all in aerospace engineering out of USC. And in graduate school, while I was getting that PhD, I did work part-time at the Jet Propulsion Laboratory on the Galileo and Cassini UV spectrometer. And was given it a go. Everything was fine, funded, grant, even had a little private office as a grad student. But frankly, government work and grant stuff was just too slow for me.
You had that experience this week. Yeah, it's awful.
Yeah, it's, you know, in this time and age when institutions are being attacked from all directions, I don't really want to pile on it, you know?
Mm-hmm. Sure. I'm
grateful that we are a strong enough and wealthy enough nation that we can fund primary science, so we can fund a space program. So overall, I'm grateful.
Mm-hmm.
But I left that to go jump into games, actually. And I built massively multiplayer online games for 30 years. I built multiple companies. I created the Starfleet Command series of Star Trek games, still considered one of the best Star Trek games ever. And did the whole series. I also moved my family to South Korea in 2003, way before South Korea was on anybody's maps, and got deep in microtransactions and online games and direct to consumer. And I was the very first person to ever get investment money from Tencent out of China, and first to get money from Nexon. Grew that. Also got money from Liberty Media, that does Discovery Channel and IAC and all sorts of things. Sold that to Zynga, became a general manager there, led Mafia Wars in Farmville.
Yeah, Zynga and Mafia Wars is no joke, right? Like all the other stuff is really interesting, and it was layers of successes, but the Zynga stuff definitely, you turned a corner there.
Oh yeah. Yeah, it's been a while now since Zynga's been out of the news cycle and everything, but at the time it was the fastest company in U.S. history to organically reach $1 billion in revenue.
Yeah.
Yeah. Farmville, we peaked at 32 million daily active users. Mafia Wars, 11 million daily active users.
Bonkers.
One famous day on Mafia Wars, we made $1 million before 10 o'clock in the morning. And so we rented a private jet and took 100 people to Las Vegas and celebrated.
I never heard that story.
Those numbers are like 1970s.
By the way, y'all,
numbers.
sorry, John, go ahead.
Those numbers are like 1970s TV channel viewers. They're just huge.
Yeah. I
was
want to
amazing.
say for the record, we're not gonna rent a jet and go to Vegas. That's not our company ethos. But I love that you did that.
But I'm already here. I'm already in Vegas.
Right.
Yeah. And then from there, moved out to Austin, Texas, fell in love with the city, built another game company, sold that game company, took a big break, and went sailing for 3 years on my boat that's named
your
Ad
boat?
Astra.
Yep. Right.
I love space. I've always loved space. I just wanted to go. There's a completely insane post of mine from 1993. I just love space and I just want to fucking go. And I just lost my mind and wrote a bunch of crazy stuff.
Good. Great. We're all there.
Very passionate about all this. Built a game called Million on Mars and built it twice. Got all really excited about Web3 and especially owning your territory on Mars. And we had a full map of Mars and we had the digital terrain maps and people could buy them and have it. And we had a lot of fun on that. Did that for a few years. But in 2022, like so many other people, AI finally showed up in big shiny lights, and I pivoted and went all in on that. And now I run a company called Bike for Mind, which is a spinoff of my Million on Mars game company. And we're dedicated to building bespoke and deep custom AI systems for enterprises. And we also run our own offering directly. And I'm having the time of my life. I am so freaking happy with AI. At any given time, I've got 3 to 7 different terminals running. I'm building on all these different projects and repos. Like, it's exhausting having this much AI help, right? Because you just don't want to sleep.
Right.
You
I was up until 4. I went to sleep at 4:40 this morning because I was just in that path. I was just in that path. The machine's helping me. I got stuff to do. There's deadlines to hit. And it's remarkable how much you can accomplish in a day with these tools. Yeah.
The insane thing right now is everything is within your grasp. Anything you can think of, you can build it. The biggest problem is like problem selection. What should we build?
Right.
Yeah. What will you build today that won't be overcome by new tooling in a month? Right. The rate of change is so crazy fast.
Yep.
And that part's hard to think through. So
we built our entire LiftPort website and the industrial infrastructure network both on Lovable. It wasn't fast and it wasn't easy, but it was a hell of a lot faster than bringing on a designer, and it was a hell of a lot easier. And the price was $400. Both of those sites are $10,000 sites just 5 years ago. Both of those sites, and one is probably going to be even more than that when we're done with it. Yeah, it's remarkable.
Absolutely. The stories are legion about what you're doing. Like, just yesterday, one of my clients has a brand new CFO, and the CFO wanted a particular NetSuite and Salesforce integration done that has a 5-figure license for it.
Yep.
Right. We just looked at that and we're like, nah. 2 years later, it was done. 2 hours later. Sorry, 2 hours. Sorry.
Yeah.
Words are hard.
Yeah, words are hard. All right, so let's talk. We got 10 minutes here. Let's talk about, what is Bike for Mind? How does it work with us? I want to preface that by saying that we have 3 AI partners. One of them, or I think 2 of them, are going to be on our call next month. One for sure, and one is still kind of quasi stealthy, so I'm not sure if they want to come out. But the other one definitely is going to be on next month, so that's exciting. And we use AI in our Notion tools. We're building a gigantic CRM in Notion. We use it in our website development and our community development. John and Sean use it every day when they're crunching numbers. So what does Bike for Mind do? And why did you and I start working together a year ago?
Those are related, but also different questions.
Yeah.
Yeah. We're both passionate about space development, first of all. Your mission with LiftPort is really one of the most romantic missions possible. How do we explore? How do we get out to space? And how do we unlock?
Boldly go.
Yeah. I especially am attracted to, right before I came on, I was attracted to your Chamber of Commerce comment around the moon.
Yeah.
I feel really excited about that. We were talking about that early on when you first were ideating that, and I believe I was a strong booster of that direction.
Yep.
And then unpacking it, actually going back to we hinted at it, but I wrote an SBR last summer, and then the government got shut down, and then we got middling scores, but ultimately didn't get selected. Okay, fine. I'm not an SBR grant writing factory. I don't. Right. That's not what I do. I've always lived direct to consumer or direct, now recently direct enterprise, and hunt and eat what I kill and things like that. But I wanted to try to write, and I put a lot of effort into it. It didn't happen. And I don't like it because, I don't hang out in Colorado. I don't know the programmer. I don't have time for all that. What I like about what LiftPort is doing is it's the most ambitious yet most practical commercial thing that I'm aware of. It's both ambitious and it's got a commercial angle to it, right? Because I want to get out of the charity business.
Right.
When it comes to space. Right? If you're just running around begging people, that is suboptimal.
Right. Well, pointing out, though, that you were able to build a complete proposal inside of 6 hours for NASA, which, having written lots of proposals, that's usually a 6-day process, not a 6-hour process.
Oh, longer than that. I've had a staff of 4 working for a month to get a decent proposal out, and you can do it in an afternoon now, and it's actually better than anything I've been able to create 10 years ago by far.
Mm-hmm.
Yeah.
Go ahead.
No. With AI, I just feel so augmented. Frankly, I'm not even the same Homo sapien I was before. I do feel transhumanist. I feel augmented. I want to think with my AI partners all the time. With Bike for Mind, going back on what that is Bike for Mind to me is similar to my wood workshop. I have a fully equipped wood workshop, got all the tools, got a saw stop so I don't chop off my fingers, just started getting into the German festivals, so I'm doing well with the tooling, really happy. But I love buying tools, I love putting it in my workshop, and I love having more and more jigs and stuff like that.
Right.
Bike for Mind is the same thing. So with Bike for Mind, we're like, what does OpenAI do? Cool. We'll copy that. What does Anthropic do? Cool. We'll copy that. Let's add that in there.
Right.
And we have all the source code to it, client side, server side, database side, the RAG, the agent layer. We're not like script kiddies that just wired up LangChain and some Python. We're not leveraging AWS's high level structures. It's our code.
Right.
And what that means is, we work for regulated industries. We've got a medical client, we've got a gaming client, and we've got a financial services client. And those people can't have their data floating around the internet willy-nilly. They just can't. And so we're able to stand up a full stack deployment where you get all the features you'd ever expect. We've got the whole web thing. We've got artifacts where you can, put up a little bit of React on the window. We have a really cool, kind of aggressive feature that's a little hobby project of mine, Questmaster. Michael, you've used it.
Love it.
Mike.
Yep. John's the guy who uses that the most. Yeah.
Yeah, I find stuff that
In fact, he went off to go use it right now. He's like, I don't even have time to talk to you guys
we've
about.
never seen.
Say again, John. We missed that comment. Go ahead.
Most of these research rows you've been down before, Michael, and we think we've done all the work using Google, and then the Quest tool throws up things that we didn't know existed, quality documents
Right.
that you can't find with a Google search.
Excellent. Thank you.
I did a complete materials matrix down select, not to figure out the material, but what's the universe of things I need to consider for figuring out what the string is. It was remarkable. Yeah,
That's awesome.
it's cool.
And so if you connect my cluttered cognitive workshop with your mission, it works out really well.
It does.
Because you guys have really specific needs. You're like, hey, I want to integrate my Notion. Hey, I want to upgrade thousands of files and I want to tag them and I want them shared in certain ways, right? We recently also wired up, Wolfram Alpha. So I'm looking literally for hard, crunchy use cases.
Yep.
And then people who have hard problems, and I have all the source code, I'm like, great, like I can wire up and integrate anything you need to be successful. That's what I find exciting and do. Like
it is.
There's so many other AI solutions out there that are, well, you want to generate some LinkedIn marketing comment, so your LinkedIn feed is full of garbage. No problem. Right. There's 58,000 people who'll do that for you.
Optimize the slop. Yeah, we don't need that. That's not what we're doing.
Yeah.
And it's worth mentioning at this point that those tools and the specialist data will be available to members of the Chamber of Commerce beyond that which you get from going in from the outside world. So we will share data between the group, and it will be valuable data that you otherwise cannot get.
That's right. And then it's been a little while since we caught up, Michael, but patterns I'm seeing come across from the other clients, I'm very confident are going to apply to you as well. But building bespoke, and we talked about a little bit, but building bespoke backends and calculators that already understand the physics and engineering around your lunar elevator. So it's not going from tabula rasa every time and trying to figure something out. It's actually getting a deterministic mathematical formula done and laying it out. We're doing that more and more. So it's mixing an LLM orchestration layer plus a data lake plus bespoke endpoints, and then it gets really really powerful. Recently, I don't know if you guys have played with it too much, but recently we also have a Bike for Mind CLI tool that mimics the capabilities of Claude Code CLI. If you want to get into that, that's amazeball stuff.
We haven't used it yet, but we have an intern coming in about 4 weeks. Let me look at the clock. 5 weeks. He's going to be here in 5 weeks. He's pretty interested in some of that code. There's a lot of chatter there. We do have somebody that's probably going to be on using those tools. We have not used them yet, so little at a time. Yeah.
That's great. And I'm attracted to people you're bringing into this network, right? I'm hoping that they are ambitious, romantic, and have crazy demands, and I'd love to figure out what they are and then wire them up.
It's coming. All right, cool. Eric at Bike for Mind, thanks so much, sir. Appreciate your time. Definitely love the service and the tools that you're providing. we're doing everything that we can with AI right now. I wish I had 4 more folks like John and Sean to add to the team, and we would be burning your servers up because they're fantastic. Thank you.
It'll happen.
Yeah.
Thank you.
Right
Cheers.
on. Thanks, Eric. Appreciate it. Bye-bye.
Bye.
All right. Sticking with our time. I did want to mention 2 things about the AI piece. We are developing our own gigantic data lake. I don't think data lake is the right word. I think it's data Pacific Ocean, right? We have really, really smart people involved with this project. We have for a long time. They have stuff hidden in the crevices of their hard drives that has never seen the light of day. They have stuff that is untrained upon data, and we are beginning to collect that as part of our onboarding process with our technical advisory council. We anticipate that we will have at least 50,000 unique files that the rest of the internet does not have access to. We've got 5 people already kind of scraping their hard drive right now. Roughly, we've got about 2,500-ish files that we're starting to collect and organize. Right now, it's a gigantic, chaotic mess, but that's the kind of stuff that we're beginning to work with. So pretty excited about that. Having our own trusted data that supersedes the chaos of the internet is very, very important. So hats off to our partners. That's one of the secret AI guy that the folks I can't really talk about right now. We've got another one, Liam, that's really focused on the engineering side of AI, and Bike for Mine. So hats off to y'all. I don't think we could be here without y'all. So thank you. All right, we're going to switch gears to Mr. Sean Key. So, Sean, we got 20 minutes. Let's talk about better futures, unknown quantity, your mailing list, the newsletters. Then we're going to kick it into, we're going to do that for 10 minutes, and then we're going to talk about the tier method for risk, and then finally bring it home with the ribbon and some of your research. All right. Of course, John, chime in as you need to.
All right, so I'm going to see what we can do with because we're having mic issues with my end. So that's going to be, bear with me, folks. I'm trying to get it resolved behind the scenes, but it's just for whatever reason it's not.
Do you want me to switch to John while you're working on that, or do you want to do that?
Yeah, switch to John. I'm going to step out, and then I'm going to try to come back in and see if that fixes it.
Okay, no problem. Right, teamwork. All right, John, you're up. That's what I love about live programming, right? All right, let me find my notes for you. There we go. All right, we're going to spend the next 17 minutes talking about trusses, Greenwich Station, Symposium, and Savage architecture. So, where do you want to start? What do you want to talk about?
Let's talk about Savage architecture to start with, or rather, some conversations and news I got at the symposium, which will lead us through to that.
Okay. Yeah, so, great.
For me,
and this is live. I have not rehearsed this with you.
No, and
you just got off an airplane, so I haven't heard any of this.
Yeah. So, one very impressive thing that I saw at the show was Off-World had a press conference where they announced their lunar habitation plans, which we've all seen lunar settlements before, and we know what they look like. They're often golf balls sitting in a crater. This is truly a city, and Jim has done something that's really quite remarkable. The huge enclosures, 10 meters under the surface, with a cylinder that's 20 meters wide and 100 meters long, huge, play soccer in them, have a park in them, growth, and it's the vision is extraordinary and a little bit insane. I think, Jim. But he's going to pull it off because he's found a way to finance this, which is also impressive. And I think he's going to leave a mark. So it's a really good story. So,
well, Jim has already commented on my post. I told him, I love this. I hope you know you've got our total support. And his response is, we're on the lunar highway together, my friends. So, yeah, birds of a feather. We're all flocking together.
Yeah, everyone's going to the moon. So someone else that's going to the moon is Kristen Savage, who's got a paper. She's launching at ICE, I think, in Puerto Rico, July this year. But to bottom line it, she's come up with she's a developer. She understands construction. She's done mega projects, and she knows how to put together these multinational mega projects. So it takes a village to raise a moon. So you can't do it with just one company. And if you do it with one government, you end up with a golf ball in a crater. So her vision is to involve heavy hitter construction and engineering companies and leverage a whole slew of companies like our Chamber of Commerce onto the job, and to run it exactly like a construction project, not to run it like a science experiment. And the gist of what she's doing is to get there inside 5 years and to do it for $5 billion and to create something that's permanent,
right?
Permanent habitation, right. Not a visit, something that people go to and they live, and it expands after that. And it's got a $5 billion price tag. But if you split that across 50 companies, it starts looking palatable. And the amount of revenue that it then generates is prodigious. So it's a clever story.
Right. Sean, change your name. Sean, are you back? Oh, no. I love all that, right? So we talked to Kristen Savage about a week and a half ago. Fascinating gal. She's done really good work. I really admire the folks that she's that are mentoring her. Caravala is one of them. Let's swing back to Caravala and his team a little bit longer. What was different about this, and how did they figure out the funding mechanism? What does that look like?
Well, I'm not sure I'm allowed to talk about the funding mechanism, but it's basically fractional sales. If you look at some of the islands in Abu Dhabi where rich people buy a slice, I think that's where he's going. But I'll leave him to explain that because I'm not sure what he released to the
okay. All right, we won't dig into that.
What he's doing is using robots. You know, he has robot tools right now, and he's done studies of robot mining. He's actually got a working Earth-side robotic mining tool. So in essence, the robots arrive and they start working, and no human goes anywhere near it until there's a big enough cavity dug out to make airtight. And that's brilliant because it's unsupervised. And he has robots that will actually do that work. We have fairly good data on the lunar subsurface. I had a vague memory of drilling on Apollo 17, and it's actually a very good insulator. So whereas on the surface, in your golf ball in a crater, you need a massive cooling and a massive heating capacity. Under the surface, 10 meters down, you can, if you've got 20 people in that 200 meter by 20 meter cavity, it gets cold very slowly. It's like minus 35 degrees C at the walls. So you need a hairdryer to keep that whole vast soccer field warm. A hairdryer. This is rule of thumb math, but a hairdryer.
Right, yeah.
So it's the kind of thing that power outages, it's very robust. And he's intending this to become a true new place for large quantities of people to live.
Was there any talk about how big, like how many people in this new city?
Yes, you need to look at his press release. So I don't want to misquote him, and I haven't talked to him in a couple of weeks in person about this. but it starts off with I don't know 3, 5, but it's going to be like 50,000 people inside 10, 15 years. Refer to Jim for the exact numbers, but it's that scale.
I have it. Because I was just looking at it a little while ago. So it's gigantic. I mean, it's thousands and thousands of people.
And
They didn't put a number on it, but which is why I was asking. But it is gigantic.
It's truly a small city, and it will be entirely self-sufficient. So it doesn't need anything coming in to make it work. And he's done the numbers on that too to prove that it works. And he wants it to be something that could survive a war or an asteroid hit or attack and keep humanity going, which I think is a noble thing to do. He's addressed details like where the landing pads go. The dust from a landing is brutal. And he's found a way to locate that away from all the structures. And he's got a train running into town. It's like coming into Venice. It's extremely well thought out. He's a fan of Space 1999. And if you squint and look at the renderings, there's a little pinch of Space 1999 there, but it's all under the surface.
Awesome. All right, let's talk about Greenwich Station and the truss, right? That's what you were working on. I'll tell everybody, we're going to be releasing these progress reports every month. Yep, I know we're already a month behind on getting them posted, but I have a lot of progress reports. I have hundreds of pages of documents ready to get posted. So was kind of hoping we were going to get them up before this show, but I didn't. So here we are. I was working until 4:30 in the morning last night, and I still couldn't get it all done. So that's what we got. But you were working on progress report number 4, focusing on the truss and Greenwich Station. So first, why is it called Greenwich Station, and what are we doing there? What are we doing there on the surface of the moon?
Okay, well, it's Greenwich Station because it's on the lunar meridian. It's smack dab in the belly button of the moon. It's where, if you look at the disk, I'm in a disk. If you look at the disk of the moon, it's right in the middle there, right. And that is where 0 is, and that's very likely where all time and date and everything will be set on the moon. So it's there, but it's actually there, aside from that, for the physics, because we have a tether that's 56,000 miles long, going from L1 down to the surface of the moon, and it's favorable to the system if we have it smack dab in the center. Some very unfortunate things happen if we're off, so it's precisely placed on the surface.
I want to remind everybody that what we're talking about is you've got the center of mass of the moon and the center of mass of the Earth, and you draw a direct line from those two center points through the surface of the moon, 0, 0, latitude, longitude at sinus Medae, through Earth Moon Lagrange point 1, pointing back towards Earth. So the physics designed this system, and we mere humans are just complying with what Mother Nature has already dictated.
Indeed. So we have a Greenwich Station, which is an anchor point that the tether is attached to, and we have some vendors under consideration for doing that. Microbores. There are companies that are already doing battleship moorings. You can moor any size of ship in sandy or rocky ground using microbores, which are filled with polymers, and that's what we aim to do on the moon. And it already works in deep ocean, so all we have to do is buy the correct lunar drilling equipment and work on our location, and we'll have a solid anchor point for the whole system.
Yeah.
And what we should tell the people listening is, you think of a tether, you're thinking of a rope you could climb up in a gym, or you're thinking of a rope ladder, and that's actually not what we're talking about. It's a very thin, I want to say, tiny piece of nylon material,
Really?
but we're dealing with weights that are 1/6 of the weight on Earth, so we can actually raise a lot of load with that tiny piece of string.
Yeah.
So
Yeah.
we have an anchor point. Conceptually, a piece of heavy fishing line is going straight up 56,000 miles to the L1 point, and we terminate it at the truss. And we terminate it with a lot of damping and other clever stuff to make the system work, some of which will be patented. But we have a truss, so a load will rise up from the moon. We're using solar panels to drive motors, very slow acceleration to reduce stress on the tether, going up to probably 300 miles an hour while it's ascending, and then slowing down equally gently as it approaches the station, the truss. And conceptually, I think a good way of visualizing this is the scene in the Bond movies where James Bond is jumping between the wires of a cable car and the system that picks up the cable car. Cable cars are not attached to the wire. Cable cars grip the wire. As I found out when I kicked the door open once in France and the cable car slipped back 20 feet and scared the hell out of us. So it's one of those interchange systems where there's an end of one and the beginning of another, and we transfer that same load in its same carrier possibly, and it goes off in the direction of Earth, using the same damping techniques and the same motors and the slow acceleration of probably 300 miles an hour, and that'll give us a surprisingly large amount of load we can move every month.
We're looking to well, you tell the numbers. How many the seed ribbon? How much cargo capacity on a kind of annual or monthly basis?
Well, there's three numbers, and we have to be conservative at the beginning. I think we started with 60 tons, and then we went to 150 tons, with a potential of 600 tons once we know the system and we fully load it. And there's a lot of issues within that because we're sending the carriers. We've got to get them back, so it's a fairly complicated piece of math. But it's out in the day, back at night. And we then have to corral all these changes. So somewhere between 60 tons and 600 tons ish is where we're shooting.
With our last 2 minutes, I just want to talk about Greenwich Station a little bit longer, because I believe that having that site located at 00 means that we're going to play a pivotal role in the communications, right? We're in this spot. We're in a known spot. And so if there's somebody in a search and rescue situation, they're going to call back and say, hey, I'm at coordinate ABC LMNOP. And if we don't have a good grid system, we won't know where that person is. Same thing if somebody finds a claim, they find a big piece of ice, or they find a big titanium deposit, or whatever it is that they're looking for, that 00 site is both vital for position navigation and timing, but also comms. So I really am excited about that piece. Honestly, that's a piece that we only really discovered, what was it, John, 3 months ago? I mean, that was, it's like, absolutely, we never really thought about it. And as soon as we thought about it, because we were originally calling it Luna Station as a generic placeholder. And then when we got to that 00, we're like, oh, yeah, it's Greenwich. Like, why wouldn't you call it Greenwich? So,
you know, I was looking at this French guy. He's made a communications map of the moon, what you can't do with surface radio, but suddenly using our capabilities, you can talk to the visible edges of the moon. You don't have to worry about craters quite so much. A very cheap low-end LoRa mesh radio network, 900 megahertz, would cover a huge swath of the moon and get telemetry from thousands of points.
Yep. All right, cool. We had a question from the audience. Yeah, we do have a safety factor. I'm not going to tell you what it is right now because we don't really like it very much. There's still research to be done on that question. And I'm just going to like riff off of that for a second. Yes, I appreciate that, Sean. We're at the top of the hour. We're going to move on here. I'm going to riff off that for a moment. Way back in my Earth elevator days, a reporter said I was a little cocky and a little sure of myself, and I responded back with, "We don't even have all the questions yet, let alone have all the answers." And I really want to stress, we don't have all the questions yet, let alone have all the answers. So it's that's why we're holding these events every month to showcase new knowledge, new breakthroughs, new problems, setbacks. We're going to be trying to be really transparent about that. But when we don't know the answer, we're going to tell you we don't know the answer. So there is a safety margin there, Joseph, but it's not a good enough safety margin, and so we're really uncomfortable with that. And that's one of the things that we're going to be working on. But that's
you want a cocky guy running a company, right? That's who you're going to invest in. You want somebody that's confident, just like a good attorney's a snake. Then you want a cocky president.
Yeah. All right, let us bring on. So we swapped out those two. Joe Luttrell, please come on down, sir.
Hey guys, how you doing?
Hey, good. Thanks for being a part of this. Hey, what are you making in the background? I see your printer running.
Okay, so I'm actually working on a mechanism that will build the spring for a new type of deployer for sending satellites out into space.
Very cool.
I couldn't find anybody who would make the spring that I needed, so I'm making it.
Because that's what we do.
That's what we do.
Yep. Okay, cool. Okay. All right. Give us a little bit about your background. Why are we getting comments that we don't have audio? I can hear you. I can hear everybody. And they're saying also no video.
Okay. Weird. That's true. Yeah, I'm frozen.
You're good. Nope. Joe, just keep talking. I can hear you. You can hear me, and everybody else is going to have to wing it.
Okay, so you can see me. All right. For whatever reason, I can't see me.
Oh, well, I can see you, so don't do anything weird. All right. So give us a little bit about your origin story. I'm going to tell people that you are one of our contractors. You are our first contractor, so thanks for that. And I'm going to not tell people what you're doing. You tell people what you're doing for us. And so what's your origin story? How'd you get into space, and what is Cube?
Okay. Well, like all superheroes, supervillains, I mean, if you looked at my LinkedIn, it says I'm one lab accident from becoming a supervillain. Yep. My origin story really starts with Apollo 11. It's a funny story because my dad was really into aerospace at the time, even though he was a carpenter. And he went out and bought a 25-inch color RCA television in 1969. Okay. That was the cost of an automobile.
Yeah.
So he could get a new car or he could get a new television. And he picked the television so we could watch the moon landing.
I like the man's priorities.
He sat us all down in front of the TV and he almost put a brick through it because the broadcast was all in black and white. So that's my origin story. I remember sitting there for the entire duration of the Apollo 11 landing. So if anybody says we have not been to the moon, I was there. I watched it. Okay. Excellent. So I'm from that era. And that led me down the path of I've done engineering in a variety of different ways. I've been a carpenter. I've been an electrician, a plumber. an aerospace engineer, software developer, video game developer, sailed boats, ran water quality engineering, which is fancy term for person who runs around in sewers, I guess.
Well, I love that. You are having technical difficulties. I'm going to post Cube's website for a moment. Hopefully Joe comes back here in a minute. Let's add him
I've
to
got something to say about Joe too. I couldn't hear a word he said, but what I appreciate about you picking him as a vendor is we have this get it done scrappy attitude, which it transcends what I see in other fast moving aerospace companies. And for very little money, he's giving us a test, which is good science. And God forbid we had a team of 9 engineers working on it, because we would have spent $1 million on this and got the exact same test. So this is quality stuff for not much money.
Thank you.
Yeah.
Absolutely.
Yeah, and that's where my focus is really narrowed into. I'm in aerospace. I did the rocketry thing back in the early 2000s. I got into the satellite industry actually because of the water quality industry, because I was seeing how bad things were on the ground. Now, mind you, the water we have in the United States is some of the best on the planet. But I can tell you that infrastructure is crumbling around us, and there's going to be accidents, and there needs to be a better way to monitor it. So aerospace, water, put them together, and there we go.
Satellite monitoring of the water system.
Completely independent from any of the ground-based systems, which have a host of problems. So that's
Gotcha.
how I got into this. I've launched 4 satellites to date. The first one you might have seen, Firefly Alpha, and its non-event at after max Q, and then followed by the boom, the flaming end pointed up instead of down, and my satellite went with it. The second one we launched, we ended up freezing to death. We learned the errors of thermodynamics when dealing with small satellites. And then the next 2 were successful. So to give you an idea, I don't know how many people understand when I say small satellites, but this is the size of some of our satellite work. Okay? That's it. And we focus on extreme miniaturization. And as John said, we're scrappy. We don't do things by the book. We follow engineering principles, but I could sit here and manufacture components and send them out and have them all space rated and do all of that fun stuff for a metal plate that's going to exist for 3 years.
Right.
Or I can build the plate, I can properly code it, and get it launched.
Right.
And so those are the 2 methodologies. So we've adopted 3D printing. The materials that we use are all space-rated materials now. So I can go from a design to a prototype in less than 2 days. And 2 days after that, I can have fully rated, space-rated hardware delivered and ready to go. So that's what I've been focusing on lately, is how fast can you produce this stuff? And
which is what y'all did for us, right?
Mhm.
That was the requirement.
Yep. I mean, here's the unit we designed. And that
Yay.
is the complete tension unit
Nice.
for space. And it doesn't look all that super, but it produces over 50 kilograms per square inch of force across the cables, the materials that you want to use for the tether.
50
And
kilos per centimeter? Per inch.
per square inch. 50 kilometers per square inch.
Okay, I can't do that math very well. Okay,
Yeah,
all right.
it's we can take 10 of the tether threads and take them all the way past the snapping point.
So let's talk about what our experiment is. We call it fast mover because that's an Air Force jargon for an inbound, usually enemy that is at supersonic speed. We wanted to go supersonic speed with this thing. You had a functioning prototype about 10 days after the check cleared. So,
Yeah.
So then describe what it is that you're building, what we required, what we're trying to get out of it. And then let's talk about our first date and then our pushed back date.
Okay.
And
Well,
you've got 10 minutes. We got 10 minutes.
10 minutes. Okay. So the idea behind this is the tether materials are, we've done a lot of testing on Earth, but there's been no in situ testing. There's no one's actually launched this to space to see if it works. So the idea behind the experiment is let's launch different types of the material, expose them to space. So they're going to get hit with atomic oxygen. They're going to get hit with all the little details of sunlight, UV, everything that the sun can throw at it. How is that going to affect it? And then temperature cycling, because lunar day is 14 Earth days, lunar night's the same. How does this material behave if you're cycling the temperature like that? And so this is a slow test. We run it through an entire breakdown of, okay, here's day one. This is what we're testing. We put the tension on the mechanism. Some of the strands will tension faster than others. And the idea is to see at what point they stress to failure. That's the whole idea behind this experiment. It's not something that you launch and it's done in 10 days. This is a very slow turtle.
Right.
It's
A very slow turtle, right?
What does this material do over the course of a year, over 2 years? And that's what we're looking at doing.
Now, what we're not doing, I don't want to mislead people. I said a moment ago, we have 14 candidate materials. We're not putting all 14 candidates in here. I'm not going to say which material we're going to use, but we've down selected the one that we're quite interested in. And what we are doing is half of those are going to be in continuous sunlight and half of them are in continuous darkness.
Correct.
And we're going to try and break them. This is a 3-year mission. It's a 3-year sun synchronous mission, which means it's not ideal. It's not the perfect Goldilocks experiment for us. Our Goldilocks experiment is go all the way out to L1 and run it there. But that's not in the budget, right?
No.
That's not what we're doing. We're doing the least possible. It's primarily digital development now. So talk about the mechanism a little bit, the process to cycle through, and then the launch.
Okay. The mechanism it's actually a set of gears. So what we're doing is we're swapping speed for torque in order to do this kind of test. So we have a motor. I am lousy at giving the specs on various hardware off the top of my head, but I can tell you that we're essentially reducing this motor to a 400-to-1 gear ratio in order to get the torque that we need for this to work. That's how we're able to miniaturize it, is you increase the torque by trading, RPM. So this is a very slow tensioning mechanism. In order to go the entire distance that we can travel takes over 10 minutes. And that distance is 2.5 centimeters, or about 1 inch. Right. Okay, so that's a very slow process. And we can stop it at any point. Yeah. There are also tension sensors to tell us what is the tension that each of the lines is basically under at any given moment. And by looking at that, if that suddenly goes to 0, we know that line is snapped.
Right. Yeah.
So, and that's a simple system.
And that's not bad news or good news. It's just information, right?
It's info. And now there's gonna be some wobble because I moved my computer closer and I put it on top of something that I need. So
okay. Do what you need to do.
All right, give me just a sec. I'm sorry, everyone. But
yeah, no worries. I will tell them a little bit about the satellite. It is it's that CubeSat size, so it is.
Yep, that's actually what I was getting.
Excellent. That's what I wanted to see. Excellent.
So this is the satellite that's currently in development for this. The entire experiment will sit in this space. Okay, our CPU cooling. Actually, it's a thermal transfer. We take the CPU heat through this ceramic element and keep the batteries warm, because that's the problem. The batteries freeze to death.
Right.
We have a full RCS, reaction control system. It includes 3 reaction wheels and 3 magnetorquers, so we can keep positioning. We have sun sensors on all sides. We have on the back, we have vacuum arc thruster, so we can actually impart 1 kilometer of total thrust to this. So that's what keeps us in orbit for 3 years. Then we also have our antennas for GPS and Iridium for our backup communications. There's also an internal camera that will be wired into this section.
And we're going to be broadcasting that camera live, so you'll know when it breaks when we know when it breaks.
Yep. And now, are we expecting high quality out of this camera? No, we're doing about 24 megapixels on this camera. No. But the more pixels you throw at it, the faster your communications line needs to be. We're running S-band, so we think we can get video, but it'll be a postage stamp at about 25 frames per second.
Yeah,
so
that is fine. We just like, this is supposed to be a dull experiment. Grass growing is more interesting. Paint drying is more interesting. We're hoping that we snap a string about every 6 months or so. So that's it. In our last 4 minutes, let's talk about manifested. I want to point out to everybody, this is the world's first dedicated space elevator experiment. The very first. Talking about it for 25 years. NASA and ESA have both sent up some ribbons, but they were not dedicated space elevator experiments. This is the first.
Yep. So in order, you got to fly it, right? Building is one thing, launching it is another. So we've started the regulatory process, and that is dependent on the launch date. And originally we were going to launch in May of this year.
In 6 weeks. 6 weeks.
6 weeks.
Right. That's why I got named Fast Mover, because we're like, holy shit, we can launch in a week. Yeah.
But the launcher that we're using is InnoSpace, and they had, as with most startups in this business, their first rocket sort of didn't make it. Right. They did identify the problem that was causing it. They've worked on the engineering, and they're fast moving as well. So now the holdup is the Brazilian government as far as our launch, and we have a no earlier than August 1 date right now. What the actual date is, we don't know. It's actually given us more time to work on the satellite and verify that everything is working. Again, I like having spare time, but I'd rather have it done. We're close to finish. We're still waiting on solar panels to arrive. And what we've done with building this small is this is as inexpensive as you can probably build a satellite of this quality.
Let's give you a moment to plug that, right? So you did this on spec for us for do you want me to tell the price? I'm fine with telling the price.
Okay. It's $60,000.
Everyone will want one.
Yeah. Hey, I'm good
everyone will want one.
Yeah, everyone will want one. It was 65,000 start to finish, and that included the launch. Now, I'm not saying that Joe is going to do that price for everybody, because launch is a different animal, but that's a pretty remarkable low price for a complex system built on spec. So hats off to you, Joe. Really, really appreciate that. Yeah.
Thank you. Yeah, normally the launch cost for something like even this small, that's a $25,000 endeavor just to launch
for
that.
Sure. Yeah.
So the fact that we've got our satellites and the deal we work with InnoSpace is exclusive to us. Yep. So that's been wonderful. They've been very gracious with helping us make this a reality. But normally, if we were to launch a satellite like this, an Earth observation satellite, we like to say cradle to grave. Yep. So from the moment we design and build to the time that it re-enters the Earth's atmosphere, that price is typically about $250,000, all in regulatory, materials, all of it. Which, I would put the challenge out there. Somebody beat me at scale. And,
Right. No. No.
because if we that's onesie twosie price. If we actually scale this down, I can get that entire cost down to $150,000.
Don't worry, Joe. We have another mission already on the books. We're
Okay.
not going to commission it yet, but we're already putting it together. So
All
you're
right.
next.
All
All
right.
right.
Sounds good.
Joe Luttrell, CEO of Cube. Love what you're doing. Thanks very much for all of your help. We couldn't be here without you. So thanks.
Michael, it's fun. I love doing this.
Right on. All right. All right. We are staying on schedule, so I'm really happy about that. We're going to try and swing back to Sean. Let's see. We've cleared up some of the background noise.
I'm hoping we have.
We haven't, but we're going to run with it anyway. So
Okay.
let's just go ahead and do it. I might cut you short if it becomes too awful, but
Fair enough. Fair enough.
I'm going to mute. I'm going to kind of ask a few questions, and then you go on automatic pilot, and then I'll see if that makes a difference. All right. So we got about 20 minutes. I want to talk about better futures and the unknown quantity, and your mailing list and the newsletters for the next 10 minutes or so. All right. All right.
Okay.
I'll see if I can go on mute and if that makes a difference.
All right. So, well, I am the CEO of Better Futures, which is a subsidiary of LiftPort Group. We produce a podcast called The Unknown Quantity, which is sponsored by the Center for Space Commerce and Finance, hosted by the director of the Center for Space Commerce and Finance, Andrew Olson, and also our esteemed Michael Lane here from LiftPort Group. And we focus on the intersection of space, money and space, basically. We had some really interesting guests over this past year. We're about to hit our 100th episode next Monday. So everybody come on over and join us in the celebration. Got to do my plug in there. But it's been a great experience. It had really exposed me to the industry. I've actually, a lot of my ideas started fostering from there about, which we'll talk about a little bit later, about the tier system. Like tomorrow, our guest is actually going to be one of our earlier guests from last year that really kind of set us off on our path, Mark Levinson, who was the author of The Box, which was about the standardization and the shipping containers and how it revolutionized global trade. And really, it sparked a lot of interest in our normal viewers. And one of our guests, not guest, but he's been a guest, but Dr. Plata, who was a physician, runs a space development group out. And that sparked them on doing some research on standardization of containers for space. So, but anyway, that's basically what the show is about, which is really falls in my wheelhouse because I have a master's degree in finance, and that's my interest. And then going on about my newsletter, which is, it's actually Better Futures newsletter. It's called the Better Futures Dispatch. And what we do, we try to tackle a topic or a subject or a business once a week that goes out on Monday mornings at 5:30 on Substack, and then it gets republished again later in the week on LinkedIn. And then it also has news links in there about, the business that goes on in space and deep tech. And then also promotional about what we offer as far as Better Futures, as far as video services and publication services, and in that regards. As far as my mailing list and the growing mailing list at Better Futures, I keep saying mine, but it's really Better Futures. Last week we had a significant jump we jumped 25 subscribers in 7 days. Usually it's a slow process because we're still building momentum. And now these subscribers, though, these are not just, a wide swath of people that are fans. These are very specific engineers, investors, entrepreneurs. I have a lot of investors. In fact, two of our next coming guests for the Unknown Quantity are subscribers, are investors that subscribe to my newsletter. So
that's one of the key things I think is so important, is that you reach outside of the space sector to reach to the general finance guy, whether it's a bank, whether it's a VC, whether it's angels, whether it's insurance. That reach is important, that we don't have, that John and I don't have.
Yeah, and that's by design. That was really my raison d'etre when I came up with the idea for the newsletter. It was, I want to reach out to people that are interested but don't know how to get in. And when I went to the space conference beginning this year here in Orlando, I'm not say here, I'm in Las Vegas, but in Orlando, I went to the VC meeting, and they said something that I had suspected all along, that the space industry is very insular. And I'm like, well, that, you know, it confirmed the thought that I had, that the space industry is very closed in, it's very much micro about itself. And I want to try to reach out and give people a window into this. There's going to be money that's interested in this industry, and they're going to want to reach into it. And I want Better Futures to be that window. So I actively, progressively go out there and I start doing that. My plan is, here in a couple of weeks, I'm still working out the details, is that at the end of the week, I'm going to do a live broadcast of the Better Futures Dispatch. So that's working on that. But right now, I do got a lot of travel, but my plan is to go pull up the dispatch again and go over it and see what, you know, because there's something I put in there, which is a signals to watch for. I can also go back and say, this is what happened this week, and then you can make a comparison. My goal is, and we'll talk about this when we talk about the tier system, my goal is not to tell you what to invest in. My goal is to paint a very clear picture of the industry that you can, because everybody has a different investment philosophy. I don't want to interfere with your investment philosophy. That's your own volition. I want to give you the tools to make your own decisions. And that's my ultimate goal, is to give you the tools to make you a more informed and better decision and make a better future.
I'm going to take
earlier in the conversation that they were talking about, there's a lot of ideas out there, and which one do you pick? And I think that the defining feature of LiftPort, outside it being a great idea, is implementation. You know how to implement investment and to get those people into the company and interested. And I know how to build stuff. I don't know the theory. I know how to actually build it. So implementation is the one thing you can't get out of an AI, and you and I bring that to the table in this company.
And it's a great synergy that I pick up with John, you know, working on a couple of the, you know, early on when we worked on the workbook together for him. And it was just, you know, we were very quick. We respond well. He bangs out the numbers for me, and I go take a look at something. And it happens very quick. We get quick answers. And we can, you know,
we have an AI that also helps. Like
yes, it makes a big difference. It's not, there's no doubt about it. It makes a humongous difference. I think it's ludicrous. If somebody comes tells me they're going to do it off the top of their head, I'm going to throw a hammer at them. That's stupid. I mean, it's dumb. You wouldn't go to a lawyer and say, I want you to defend me off of what you can remember about the law. No, I want you to open every damn book that you can. Use whatever tool, you know, within reason, you know. So that's my take. Use what you got.
I'm gonna take a moment to kind of talk about the heritage of Better Futures, because it did actually predate you. What's that, John? Yeah, I'm going to talk a little bit about the heritage that predated you. We wound up building online conferences during the pandemic as a way of just keeping the lights on. We did, hundreds of hours of online conferences. We did 34 distinct conferences. And since then, a couple hundred hours, almost 500 hours worth of online content. Yeah, it's really quite amazing. And so Sean inherited that body of work that preceded him. And, in just the last maybe 2 months, just slightly over 2 months, we've gotten 40,000 views of our prior content. So that's pretty remarkable. So that's a new accomplishment from Sean.
Yeah. And also same thing with going back to the unknown quantity, seeing it grow from what we started with.
Mm-hmm.
We're starting to see some real traction. We're also on Spotify. We're on Apple Music. Apple Music's doing really gangbusters, even better than Spotify, which I'm really happy and pleased about. And then, and Jonathan's back. We bring him back in.
Yeah,
there we go.
I'm back.
Yeah, and that shared history of Better Futures that I inherited when I took over, I'm trying to go back and leverage it into. There's a lot of information there that's really relevant, and we really got to dig. And AI does help, but you have to download the transcript. It's a very manual process to download, and it takes time because you're going from video to transcript into the AI. And so that takes a little bit of time and effort. And sometimes I'm a little stretched thin at times, but I'll figure it out.
All right, we've got 9 minutes. Let's switch gears to talk about what you've been working on recently. I want people to understand Better Futures is not a side hustle that we're doing to make money. We did have to do that to stay alive during the bad days of the pandemic. We did. Absolutely. It was not a side hustle. It was the only form of cash for several years. Now, with this kind of redevelopment, bringing this team together and really doubling down on building the elevator, I brought Sean in to specifically take over because we don't want to lose the resource that we have. We don't want to lose the asset that we have. LiftPort's business model is to commercialize intellectual property that leads us towards the space elevator. Like that's what we're doing. And so there was a conversation about whether to cut or keep Better Futures, and the unanimous decision was keep it, right? It's a valuable asset. And it is a communications tool, right? We're running this show off of the experience that we learned from doing all of those shows before. Yep. So we're not going to cut it. It's vitally important. And it's part of those 4 pillars that we sometimes talk about: hardware, business, outreach, and framework. This is the outreach component, right? So we're going to have more shows, not less. More content, not less. But Sean doesn't actually have that media background. What he is a finance guy. So Sean, switch gears, put on your other finance hat now, and talk about the tier method and the work that you did for the materials.
Okay.
And
all right. So
7 minutes to keep on track.
Okay, so the tier method is a framework I've worked out. And the theory is, and it's not really a theory, is that you can figure out there's always been a history that you kind of guess what the risk level is for these uncharted territories. And I disagree with that. I think you can chart it out. And so I built a model where I don't invent new math. I do not invent new business procedures. It's just an additional layer to cover these frontier markets. And all I did was figure out the 4 dimensions of risk, which is going to be the technology itself, the environment, regulatory requirements, and the market. And then you come up with a composite score. And then you figure out, all right, so if you got a new company, you have to use a proxy for your base, add your composite score, which is rated depending on which is more important. And then you have a proxy score, which is no different than you'll find like in a company that's issuing debt. If you don't have much corporate history, you're going to get a higher credit rating. So a required rate of return. So that's no different than what you see anywhere else. It's a basic finance. But when I got that score, I realized I can chart it. So I would develop a tier scale. So tier scale starts off with tier 3, which is theoretical, tier 2, which is development, tier 1, which is scaling, and tier 0, which is where you actually are just a normal operating business, just happens to work in space, or happens to work in AI, or happens to work in robotics. It works across any frontier technology. So when you got a tier score, you can plot your company on the tier level and watch it as it develops and matures. You can watch that risk rate go down, and you can watch it go down. And not only can you do that, that intrinsic risk score that you just got, you can compare it to the market rate. You compare it to the historical rate, and that will give you a lot of data about pricing, how the market is pricing the company, the asset at that time, or how it has priced in the past, and what's the gaps between those. There's a lot of detailed data in there. And then going on off the tier scale, I've also had the tier ratio, which takes the industry, like space. We figure out what the critical sector is, which tells you whether it is going to, it's the sector in an industry that if it doesn't exist, the industry will have a hard time existing or a hard time scaling. And so in space is launch. It's quite easy. The space is probably the easiest one, is launch. So when you set that up as your critical sector, and then you line everything up upstream and downstream, guess what? I just made a heat map. You find out where investments go. Oh, it's all going upstream. Well, what about downstream? I mean, it's going downstream. What about upstream? Well, there's going to be a demand going on here. I mean, if it doesn't get filled, we're going to have bottlenecks. So, I mean, there's a very valuable tool, and I've developed it as a way for me to understand. It was also a way to help to explain to people what is going on in the industry. I can do it on a map, so all I have to look and like, oh, okay, that's really simple. It's nothing rocket scientist. I'm not like John over there. I'm not trying to figure out physics or anything. I'm just trying to solve a simple problem and give people an explanation and say, look, this is what's going on. All right. And I say like this all the time. I'm building a map. You're the compass. So orientate yourself to the map and follow your compass. So, and that became the theme of what Better Futures does at reaching out. For is what we do within the company. It is definitely that. We are very important to IP, intellectual property. Right. We have to get the message out there. And that's part of our process there. But that's really what the tier system was about. And not only could I do that in the space, I could do it, like I said, in robotics, material science. It all depends. You can sit down, orientate it, and go from there. So let's talk about the...
Yeah, right. I need you to talk.
Let's go talk about the NEMA because we're running out of time. I'll be real quick about it. The NEMA, which is, make sure I got the name right, ultra high molecular weight well, it starts with P, polyethylene. So I'll get it through. I didn't have time to practice because I've been running behind time the whole thing with grandkids and stuff. But anyway, that stuff is surprisingly the tether itself is probably going to be the cheapest thing on the rocket, on the whole thing. That's what.
Say that again, because everybody's surprised by that.
It is probably going to be the cheapest material on the whole entire project. Mm-hmm. Even with a basic amount that we're going to need, usually I got the numbers right here. I'm sorry about that, guys. I'm pulling it up here. I had all this pulled up already on the chart. So the raw fiber for that material I just said that I'm not going to butcher again. It can be between $10 to $20 a pound, depending on the provider. All right, and the amount that we need can be made globally, quite easily, actually. And so, aerospace cutting, $25 to $50 per pound. Yep. We don't need that many pounds compared to what you think we do, which is surprising. That was the one thing that caught me off guard. And when I told him, I said, "Look, this stuff is actually fairly cheap." And we were really excited. Then I started looking at rocket launches, and I'm like, I'm not so excited anymore. But that's a different story.
Right. Talk in your last minute about lead times, because that might be the killer for this whole thing.
Say that again.
Lead times. Talk about lead times, because while it's cheaper than we ever thought it could be, it also takes a while.
It does take a while. It will take a while. I don't have the lead times pulled up, but when we talked about it 3 months ago, I really needed to get this going now.
Yeah, yeah.
To really
Yeah.
get started to try to hit a sooner deadline.
And
And-
John is especially concerned about gluing different spools together, because this stuff comes
Yeah.
off
Joining's a
in
challenge.
30-kilometer rolls. Well, if we got 150,000-kilometer roll, that's a lot of knots, right? That's a lot of
Yes.
glue. So
Yeah, the takeaway I just got from the it's cheap discussion is, of course, we scale indefinitely, because if one tether is cheap, then two tethers are cheap, and we double the capacity, and you can carry on doing that math to I don't know when, but
Yep.
you can end
you
up
just
pulling
lay them out side by side, and you just get bigger and wider. Yep.
Yeah.
And the other thing I loved about Sean's method is he can incorporate TRLs, the standard aerospace industry measurement, with these unquantifiable, almost sentiment ideas, and come up with a hard number. And I've never seen that before anyway.
Yeah. Well, I'm a firm believer. I don't want to reinvent the wheel. Somebody already did that. So when I looked at TRL, now I'll give you a tip on how I did it. The way that we're numbered, it's 10 is when it's ready to go. And well, and let's invert that. Invert the numbering system, keep the scale like it is, but invert the numbering system, and then it's a countdown. And as it get closer to time to go and it'd be a market ready, it's a 0. Well, that's the way risk works. As the closer you get to being operational and fully operational, you get closer to 0. So that made sense to me. And so that's how the other dynamics worked. I worked them out the same way.
All right, cool. We got 20 minutes left. Let's bring on Wes. Wes, we've got about 12 minutes. There's a few things I want to talk about before we close out. So I'm going to cut your time a tiny bit. Let's see what we can do in 10 minutes. And if we need 12, we can. Or if we need 15, we can. All right? All right.
Is my background still? Can you hear me? Can you see me?
You are good.
Fuzzy.
Yeah.
I didn't mean for that the background to be like a static black and white TV, but
It looks good, man. It's fine.
yeah.
Here we are.
I'll allow it.
I'll allow it.
My name is Wes Ferris, and I'm coming into this LiftPort group with coming from the intersection of private property rights and outer space. I want to get through the backstory as fast as I can so that we can get to what's going on now. So I went to NASA Space Camp at Titusville in 1993. I'll start there. That's where my interest in space began. I was at the University of Tennessee in 2003, and I saw a clip of on Conan O'Brien of a guy named Dennis Hope that was selling real estate on the moon. I thought that was interesting. I called him up and asked him legally speaking, what did you do to be able to be in a position to sell property rights on the moon? And then I'm figuring, sweet, all right, if this guy can just arbitrarily do this, I'm going to arbitrarily pick 3 stars and go to the Knox County Recorder's Office with a document typed up saying that I own these 3 stars, get it filed, and then go to the news and then get on the Knoxville News. So I did both of those things. It's a party trick at that point, but but it worked.
Well, no, say that again. It was a party trick at that
party
point,
trick,
right? And which 3 stars did you pick?
I claimed ownership of the 3 stars of Orion's Belt.
3 stars of Orion's Belt.
So
I mean, I gotta say that's pretty ballsy. So
That's a lot of stuff.
And I actually looked into it while I was digging into the Outer Space Treaty, and the justification for at the time by Dennis Hope was that, and this still applies today, that in 1967 the U.S., Russian governments, and now there's 118 signatories on this United Nations Outer Space Treaty. Basically, it essentially says that no country can annex the moon or any other celestial body, but it doesn't say anything about private citizens, because at the time, it was only speaking to nations. And also there's this other treaty, which I'll get to later, called the Moon Treaty, which is like the runt of the Outer Space Treaty system. There's like 17 countries on board with it. It tried to block private property rights and set up an international organization where only it has property rights. So I figure Orion's Belt's way outside of that too.
Right.
So,
right.
yeah, so there's no argument there.
But it's also stress, right? That you have a law degree and a certificate from this university.
It's
So
a graduate.
you're not some like rando hack that's doing this party trick. Like,
Right.
you have a legit real estate background and you're applying it to an edge case in the solar system.
Correct. At that point, I didn't have I graduated from Tennessee in 2005 with a Bachelor of Science in Communications. But then it dawned on me, like, I don't like the answer that nobody's gotten yet. Like, is private property rights a violation of the Outer Space Treaty, or just the lack of it wasn't mentioned at the time.
Right.
So I did some international studies at the University of Aberdeen abroad, and I tried to figure out what is. I saw somebody named Greg Nimitz that tried to sue NASA for a parking fee on an asteroid that he claimed. The courts threw it out. So, what is the best way to get the answer at that point without trying to squeeze it from a court that can't give it, without litigation, with no violation of the Outer Space Treaty? What's the best possible way to render that answer? Who do you even go to? And so I sent the letter to NASA's head legal counsel. They said there's two entities that can give the answer. One is it's a mouthful, United States Department of State, Bureau of Oceans, International Economic and Scientific Affairs, Space and Advanced Technology Division. And the other is within the United Nations Office of Outer Space Affairs. Turns out that the same people represent us at the now currently going on UN Committee on Peaceful Uses of Outer Space. So in 2007, I wormed my way in to I think at that time it had to be the only private sector person that wasn't a government entity into the currently going on UN Committee on Peaceful Uses of Outer Space Legal Subcommittee. I can tell this because I had a badge that said private sector on it and nobody else did. and somebody ends up getting so mad at me for this letter I disseminated to various delegates by placing it on their desk and in their little wooden mailboxes against the Moon Treaty. Not because of what I said, but because I was not an international intergovernmental entity.
Right.
So
private citizen in a place that you don't belong. All right. Well, let's talk about for a second. You're a contractor. I'm not going to talk about what the project is right now because that is still very quiet. We're going to be quiet about that. But what do you see as property rights on the moon, property rights in the solar system? One thing I will tell people is that we are going to start working on a white paper to clarify our position on space property rights, because we're going to plop something down at Science Midday and we want to make sure that we've actually got clearance for that. So that's pretty straightforward. So why do you think people should care, and why should LiftPort bring on the contract? Like, everybody, I think, understands why we would bring on Joe Luttrell to build a satellite for us for Cube. Everybody understands why we should bring on Eric Bethke at Bike for Mine. Like, those seem pretty obvious. Your stuff is a little out there. So why should we do it? Why should we do it now at this stage?
I consider myself the first person that cut the red tape on getting the answer that private property rights are not in a violation of the Outer Space Treaty.
Exactly.
And I'd like to keep it that way.
Yeah.
Like keep the red tape that's been cut.
And keep it cut. Yeah.
So that's exactly why your project intersects with that in such a way that I would like to hear not only from I've heard it from the U.S. government about 7 different times now, I'd like to hear it from I'd like to synergize a way going forward where the method and the justification of why we're doing this, everybody's on board with. So,
let's be clear. You didn't get official permission to claim a star. You didn't get official permission to claim an asteroid. What you got was fill in the blank.
what I got was a confirmation that that a claim in and of itself by a private citizen is not in violation of the Outer Space Treaty. That's the way I phrased it. I saw so many other people doing it wrong, and I saw so much like justification of the lack of any answer automatically means one thing or the other. So yeah, it's the
And that's the very best that is possible right now. All you can get is it doesn't violate. No one has granting authority to say, yes, you've got it. Nobody can approve a claim. All they can do is say you don't violate the current rules.
right. So within the Outer Space Treaty, that's true. Now, 4 countries have passed legislation: U.S., UAE, Japan, and Luxembourg, saying that it's the extracted resources. We're going to pass a law in favor of that, saying that it doesn't violate the Outer Space Treaty.
Great.
We're talking about the subsurface versus extracted resources. Nothing's been written still yet on really the surface and underlying surface rights. So for now, while everything's still getting hashed out, I'd like an admission from everybody else that's working on this on the United Nations level that there's nothing that, like, while 4 countries have said you could bring back stuff and it doesn't violate the Outer Space Treaty, there's still nothing that says, outside of the Moon Treaty, that says that you can't that there's the potential for in situ resources for the private sector can't move forward. So that's how I kind of want to phrase that white paper. I'd like to have this done in the next couple months, so we can talk about what's going on. And the UN meeting just started today, so I don't really have too much there.
Sure.
Thanks for question.
Our goal here with this white paper is just to get a community of really smart people that all have the same basic philosophy of private companies should be able to just pick up a rock. If they did the work to get that rock, they should have entitlement to the value of that rock, right? That's all we're trying to say. We're not trying to like carve up the moon in plots and say this is mine and this is yours and we're going to fight over it. That's not what this is about. We just want to have a document that smart legal scholars in the space sector that have skin in the game can all agree on and say, we agree that this is the path forward. It's not the Artemis Accords. It's not a nation state doing it. It's a private sector decision that we believe will lead to common law practices, right? Ultimately, something like that. Yeah.
What I like about this is it opens the door to free enterprise. And, the West wasn't opened up by governments. It was opened up by private enterprise. And that's what you're facilitating, Wes, the growth of space.
Yeah, it's really neat stuff. All right. Do you have anything else? Because I'm going to close it out here in a second. Does anybody have anything else?
Yeah, I'd like to close by saying that right now the Committee on Peaceful Uses of Outer Space is working on the first building blocks of what might be a new treaty someday, and so it's called the Working Group on Space Resource Utilization, so we get to hear all the back and forth on what's said. There's interesting stuff that some countries are saying and some countries are defending, but the goal is to have something that that is signable and kind of legally respected by next year. So,
Wow.
And that's happening now.
Okay. All right. So keep us posted. All right. We'll bring you back again next month to give an update with the rest of our contractors. All right. Thanks a lot, Wes. Appreciate it. And in our last 5 minutes, John, Sean, do you have anything you want to chat about?
Well, yeah, just briefly. It was my first space symposium this week, hopefully the first of many. And Douglas Adams, Hitchhiker's Guide, wrote this line about rocket scientists don't get invited to those kind of parties. Well, they do, and they're happening at Space Symposium. So I suggest we change the name of Space Symposium to Burning Man in a Black Suit, because that's more appropriate.
Oh my gosh. I have stories about Symposium. Symposium
There you go.
is old school space, right? And if you ever saw any of the like the 80s versions of Defense Department parties, Symposium used to be that. It used to be called the spring break of space. It was wild once upon a time. All right. That's not where we are today. In our last couple of minutes, I just want to kind of point out a few things. We're launching the Industrial Infrastructure Network, the Chamber of Commerce for the Moon. That's a real thing. Like, that is beginning to happen now today. We're building out our advisory council. We already have let's say 10 to begin with, but I think we're going to have 100. That's really important because that's direct intellectual property that we'll have access to that other people don't have access to. We're starting the capital raise. That's I interviewed an attorney last week on Friday. I interviewed another attorney this morning. I'm going to have another talk with them with a different one on Monday. Those two attorneys are very different from each other, and they each bring something very powerful to the table. But I stress to them, the legal documents is the easiest part. What we all need is capital. No industry eats capital the way this industry eats money. So one of the answers was we can have money in 90 days, and the other one said money's the easy part for us. And it's a law firm with 1,250 lawyers, so it might be the easy part for them. So we'll see how that goes. I do want to tell you that there's 2 proposals that are out that I got out this week. One for a group called Asgardia, which is one of the largest space nonprofits out there. We're trying to build a better future style conference series for them, but it's gigantic. It could be very important. We don't know the answer to that. We proposed this 5 years ago and got shot down, but we were intentionally re-asked to resubmit. So I've done that. And then also, so that just went out yesterday. And then also first thing this morning, we were invited to give a presentation to the nation of Malta, which is super weird to me, but I just finished 2 7-page proposals to Malta, and they've already scheduled a meeting with us for next week. So I don't have any idea whether either of these things is real or substantive. I don't have any insights. I don't have any crystal balls. Both of them are very substantial, and they lead this project to another degree of success. So fingers crossed. I'll let you know how it goes next month. And with that, I'm going to sign off. For Sean Key and Jonathan Connell, I appreciate everybody who's a part of this. For all of our contractors, Wes and Eric and Joe, we can't do it without y'all. So I appreciate it. And with all of our fans that keep the lights on, for all of our fans who keep the lights on here, this candle war that burnt out years ago if it hadn't been for y'all. So thank you so much, because we couldn't have done it. We couldn't have tried 5 times to build an elevator if it wasn't for y'all. So thank you so much. And with that, we're out.